So this is the very first deviation in our book on after the introduction of the prism. So let me explain it. So here we direct an incident ray on this surface of the prism and makes an angle of incidence I1, which we name I1. All right. Then here we draw a normal, which is perpendicular to the surface, right? So it bends towards the normal. You see, this is the refracted ray. This is a refracted ray. It bends towards the normal. Now, by how much is it bending? It was supposed to go this way by this dotted line, as you can see. But what happens is that it bends this way. This way. It was supposed to go in this line, but it bends this way. So what is actually happening? It is turning by this angle. So this is the angle of deviation 1, because we are taking this as I1. So just for uniformity and understanding better, we are taking it as angle of deviation number 1. And then this is the way it goes and it hits this surface. This is the refracted ray, and angle of refraction with the refracted ray and the normal is R1. Okay, so it goes this way, it hits this surface. Again we draw a normal which is perpendicular to this surface, this prism of surface. Then this is the angle of incidence. This R2 is actually the angle of incidence, but you see we have a whole lot of equation to do, and to make it clearer and understand and uniform derivation, as you can see there are so many formulas R1, R2. So for that uniformity we are taking it as R2, but what it actually is, the angle of refraction at the second surface. Again it bends towards the normal, and this is the emergent ray. So it comes out. Now we trace it back. This emergent ray, we trace it back, and it meets at this point with the tracing back of the incident ray. So we trace back both the emergent and the incident rays, and they meet at a point which I have named M here. I think even in the book it's named M. And this is the angle of deviation. That is the angle by which the incident ray has deviated to come out as the emergent ray. Now the solving part comes from triangle PMQ. Which is the triangle PMQ? This is the triangle PMQ. This triangle PMQ. Okay, this triangle, we can calculate this angle. You apply the theorem that the exterior angle is equal to the sum of interior opposite angles. These are two interior opposite angles, so the sum of these two is this angle. So that's what I have written. Sum of two interior angles equals to exterior angle. I have written the names of the angle. You don't have to write it, considering it's named in the diagram. You can directly say deviation 1 plus deviation 2 is equal to deviation. Now deviation 1, as I said, deviation 1 is the value by which the incident ray has turned to form the refracted ray. So by what angle it has turned, that is what the deviation 1 represents. So the value of deviation 1 can be written as I1 minus R1. So that's what it is written here, I1 minus R1 plus, because once again this was deviation 1 plus deviation 2. So this is the value of deviation 1. Now deviation 2, once again here in class Miss said that you can apply the principle of reversibility. So if the ray is directed this way, now the angle of incidence becomes this, and the angle of refraction becomes this. One more reason why it's written I1, I2 and R2. Okay, so it goes this way, and again it is supposed to go this way, but it is refracting by this angle, by which angle of deviation 2. So the angle of deviation 2 can also be written as I2 minus R2, as I have written it here. Just substitute the values from here. This is substituted to this. We are rearranging it. I1 plus I2 minus R1 minus R2 can be written as minus, and in brackets R1 plus R2. This is the first equation. Not exactly the first equation, I've named it for reference. Okay, the main equations you refer it from the book only. This is for my explanation, I wrote it this way. Now we are taking the quadrilateral APNQ. That is the quadrilateral APNQ. This quadrilateral, right? This one, this whole quadrilateral. Now here we find that this, as said, that the normal striking the surface at 90 degree, not normal, normal is drawn perpendicular to the surface, right? So since this is 90 degree, even this angle will be 90 degree because it's a straight line. So the two sum is 180 degree. They're supplementary angles. So this, if this is 90 degree, this is 90 degree. Similarly here, if this one is 90 degree, then this one's also 90 degree. So what we get is that this angle and this angle of the quadrilateral is equal to 90 degrees. It's given. I've just named the angle, okay, equals to 90 degree from figure because I have drawn it this way. And then as we know, the sum of all the angles in a quadrilateral equals to 360 degree, okay. Now keeping the angle P and Q, this angle, as the focus, what we do is we substitute the values, all the angles 360 degree, then these two angles we knew, so minus 20 degree gives us 180 degree, P and Q are taking as and this angle, this is angle A, or the refracting angle, I guess I can't, just let me verify the name. I think it's the refractive angle of the prism. Just a second. Yes, it is the angle of prism. It is the angle of prism A as it's given in the book, right? So this is the angle of prism, so we are substituting it by that same value A. So angle P and Q, this angle, once again don't lose track, this angle is equal to 180 degree minus A. Another equation we got. Now in triangle P and Q, what is the triangle P and Q? This triangle P and Q, this triangle. What we get is that the value of angle P and Q, the value of angle P and Q from this triangle is 180 degree minus R1 plus R2, sum of all angles in the triangle, right? So that's what I've written here. This is 3. Now from 2 and 3, I've written it this way to ensure that minimum confusion is there, right? So this is 2, 3. So from 2 and 3, what we get, we can equate these two because both are the values of P and Q, angle P and Q. So what we get is A equals to R1 plus R2, and this is, yes, this one is the main, this equation I'm talking about. In our book too, it's written very clearly, but this above explanation makes it a little complicated and very demotivating to go through. I admit that's the sole reason why I did it myself, and also because Miss said, okay. So we got this value, A equals to R1 plus R2. Now from 1 and 4, what is 1 and 4? You can see, just go through once, what is 1 and 4? 1 is this, 4 is this. Now from here what we are getting is, we are getting the value of R1 plus R2. So we are here substituting it, I1 plus I2 minus A, I1 plus I2 minus A. Rearrange it, I1 plus, this becomes deviation plus A. This is the final equation, I1 plus I2 equals to deviation plus A. Just till here the deviation is there.